Hey, what's up? You already know who it is. It's your boy, Strata. A learning target says I could use proportions to solve for missing sides in overlapping similar triangles. All right, let's get to it. So for our first example, it says in the diagram below of triangle ACD, E is a point on AD and B is a point on AC such that EB is parallel to DC. If AE equals 3, ED equals 6, and DC equals 15, find the length of EB. So I'm going to first take this information they gave me here, and I'm going to label my diagram. So it says AE is 3, ED is 6, and DC is 15. Okay, now I'm going to go ahead and say to you that triangle AEB is similar to triangle ADC. And I can actually prove that to you. I can prove to you that this little triangle is similar to the big triangle. And I will actually prove that to you later on. I'm not going to get into the proof right now. For now, I'm just going to tell you that they are similar, and I'm going to prove it to you later on. What I want to focus on is knowing that they're similar, how do you solve for the missing side EB? And I'm going to give you a strategy to do that. So what I'm going to do is I'm going to separate the overlapping triangle. So I'm going to take the little triangle, I'm just going to put it here. I'm going to label the vertices A, E, and B. And I'm going to label the sides they gave me. AE is 3, EB is X. Now I'm going to take the big triangle and I'm going to put it here. Some room there. And let me move some stuff around so it doesn't get too cluttered in there. So I know that the vertices of the big triangle are A, C, D. So I'm going to say this is A, C, and D. And I know that DC is 15. So I'm going to write 15 here for DC. Now, what's the length of AD? AD is actually, that's a D. Let me rewrite that. AD is actually the sum of AE and ED. So if you want to get AD, you need to add AE and ED, so that's going to be 3 plus 6, which is 9. So AD is 9. Now remember what I said earlier. These triangles are similar. The little triangle is similar to the big triangle ADC. So since they're similar, I know that I can make a proportion to relate the sides. So I can make a proportion such as this one. AE over EB is equal to AD over DC. And I can use this proportion to solve for X. So I'm going to substitute. I get 3 over X equals 9 over 15. Now I'm going to cross multiply. And from that cross multiplication, I get 9x equals 45. So now I divide both sides by 9. So I get x equals 5. So x is equal to 5. So if x equals 5, that means EB is 5. So EB is equal to 5. That's our final answer. Okay, so these are some steps that you could use to solve for missing sides in overlapping triangles. Okay, you're going to notice that I put a little asterisk on step 3 where it says label the sides of the separated triangles, because you really need to be careful with step 3. You got to be very careful with it, because as you saw in our problem, when it came time to labeling AD was the sum of AE and ED, and you have to be aware of that. If you're looking for a whole side, you need to add the parts that make up that side. So just be very careful with step 3 when you're labeling the sides of your separated triangles. Okay, as promised, I told you I would give you a proof for why the overlapping triangles are similar. So let me begin with some of the information that we are given. We are told that line EB is parallel to line DC. So I'm going to label that in the diagram. Okay, usually when I'm given parallel lines and I'm trying to do a proof, I'm going to look for either alternate interior angles or corresponding angles. And in this case, I have corresponding angles here and here. So when you separate this, so let's bring that here, and let's bring that here. And we got A, E, B, and we got A, E, C. So far, I know that angle E here is equal to angle D here, because they are corresponding angles. So I'm just going to go ahead and write that. Angle AEB is congruent to angle, what is that, ADC, because they are corresponding since DB is parallel to DC. So I got one pair of angles now. The second pair is going to be angle A here is congruent to angle A, and that's going to be because of the reflexive property. So I'm going to go ahead and write that. Let's extend the page here, so I'm going to just say angle A, and then you can say angle A is congruent to angle A, or you could even say angle EAB is congruent to angle BAC, whatever, but I'm just going to say angle A is congruent to angle A by the reflexive property. Just typo here, let's say corresponding, and angle A is congruent to angle A by the reflexive property. Let me try to stay consistent with the fonts. And then now you can say the triangles are similar because of the angle-angle theorem. So I'm going to go ahead and say triangle AEB is similar to triangle, what is it, ADC by AA theorem. And that's the proof. So let's review it real quick. So the first one says angle AEB and angle ADC, that's these angles here, are congruent. Angle AEB is congruent to angle ADC because they are corresponding since EB is parallel to DC. Remember, this line here is parallel to this line here, to line DC, and then this is acting like a transversal. So these are your corresponding angles. That's how we get that. And then angle A is congruent to angle A. So you look at angle A is being shared. Angle A is being shared by the little triangle and the big triangle. So that means angle A is congruent to angle A by the reflexive property. And then, once you got that, you could say that they're similar, right? Because if you could show that two pairs of corresponding angles are congruent in triangles, that's sufficient to say that the triangles are similar. Okay, I hope this video helps. Take care.